Welcome. This is the homework solution for Thursday, January 24. Number 1, it says to solve the system of equations by elimination. So I'm going to solve by elimination because the coefficient of y are opposites. Step 1, I'm going to check that the coefficient of one of the variables are opposites. Notice this is a plus 4, this is a minus 4 for the y. Therefore, elimination would be the correct solution method. Step 2, I'm going to add the two equations together. One variable should disappear in the process. 7x plus 9x gets me 16x. 4x plus negative 4y. 4y plus negative 4y gets me 0. See how it disappears? 2 plus 30 gets me 32. What I have left is step 3. Simplify and solve for the variable. 16x equals to 32. That's what I have left over. Divide by 16 to both sides to solve for x. So x equals to 2. Step 4. I'm going to substitute the solved variable back into the original to get the other variable. So I have 7x plus 4y equals to 2, which is my first equation. I'm going to substitute x equals to 2 because that is what my x value was. X was 2. 7 times 2 is 14. That is how I got the 14 here. Everything else remains here. So now I'm going to subtract 14 to both sides. 2 subtract 14 is negative 12. I have 4y equals to negative 12. Divide by 4 to both sides. I get y equals to negative 3 because negative 12 divided by 4 is negative 3. So the solution of a system is always in the format of an ordered pair. The solution here would be 2, negative 3 because the ordered pair is x, y. Number 2, solve the system of equation by elimination. I'm going to solve by elimination because the coefficient of y are opposites. Okay? I'm going to check that the coefficient of one of the variables are opposites. They are not. So we need to make them something else. Notice how the second one here, I'm going to multiply by negative 2. Why do I multiply by negative 2? Look. Okay. If the bottom one is multiplied by my negative 2, the coefficient becomes opposite. Look. The top one is still 3x minus 4y equals to negative 5. That does not change. The multiplication by negative 2 only affects the second equation. So negative 2 times 5x gets negative 10x. Negative 2 times negative 2y gets me positive 4y. Negative 2 times negative 6 gets me 12. So we are good now. I checked that the coefficient of one of the variables are opposite, negative 4y and positive 4y. The coefficient are now opposites. So now we can repeat like number 1. We can add the two equations together. One variable should disappear. Okay, 3x plus negative 10x gets me negative 7x. Negative 4y plus 4y gets me 0. Negative 4y plus 4y becomes 0. Notice how it disappears. That is the reason, again, why we multiply by negative 2 here. So this would be a positive 4. Because see how it disappears here? This, step 1 is step 1 here, should make sense because we're trying to eliminate something. Okay? Negative 5 plus negative 5 plus 12 is 7. So, step 3, I can simplify and solve for the variable, which was negative 7x equals to 7 was what I have left. Divide by 7 to both sides, I get x equals to negative 1. Step 4, you can substitute the solved variable back into the original to get the other variable. 3x minus 4y equals to negative 5. That is my first equation. I can substitute x equals to negative 1 back in because that is what I solved for. 3 times negative 1 is negative 3. Everything else comes down exactly the same. So now I can add 3 to both sides because that is how I get rid of the negative 3. I have negative 4y equals to negative 2 left over. Divide by negative 4 to both sides. I get 2 over 4 or 1/2. A negative over a negative is always a positive. That is why my y value is a positive 2 over 4 or 1/2. So the solution for the system is always in the format of an ordered pair. The correct answer is negative 1 comma 1/2. Negative 1 comes from the x. The 1/2 comes from the y. This is number 3. I'm going to solve the system of equation by elimination. I'm going to solve by elimination because the coefficient of y are opposites. Notice it is 2x plus 3y equals to 8 and 3x plus 2y equals to 7. Step 1, to always check that the coefficient of one of the variables are opposites. They are not, so this time we have to make both of them. So the first one I'm going to multiply by 3, okay? And the second one I'm going to multiply by negative 2. Why? Because look, 2 and 3, right? The number that they have that they are a factor of are 6, okay? So I'm trying to make this a 6x and I'm trying to make this a negative 6x. So when I combine them, they disappear. Okay? The number 3 and the number 2, they're both factors of 6. That's why I multiply by these two values. Now, let's check again. The top equation was multiplied by a 3. So 3 times 2x is 6x. 3 times 3y is 9y. 3 times 8 is 24. Second step, multiply the second equation by negative 2. Negative 2 times 3x is negative 6x. Negative 2 times 2y is negative 4y. Negative 2 times 7 is negative 14. We are now good because here notice that the coefficient in front of the x are opposites. Step 2. Add the two equations together. One variable should disappear. 6x plus negative 6x becomes 0. It disappeared. 9y plus negative 4y becomes 5y. 24 plus negative 14 is 10. Step 3. I can now simplify and solve for the variable. 5y equals to 10. Divide by 5 to both sides. I get y equals to 2. Step 4. I can now substitute the solved variable back into original to get the other variable. 2x plus 3y equals to 8 is my first equation. I substitute in 2 for the y, which was what I just solved for. I get 2x plus 6 equals to 8. Now I subtract 6 to both sides to get the variable alone. I have now left 2x equals to 2. 8 subtract 6 is 2. Divide by 2 to both sides. 2 divided by 2 is 1, so x equals to 1. The solution of a system is always in the format of an ordered pair. So the correct answer is 1, 2, because the ordered pair is x, y. There you go. Number 3 would be as hard as it's going to get. Okay, sometimes you might see a fraction. Okay, but we're trying to keep the numbers pretty here. Alright, there you go. Those are all your homework problem solutions.